Now I take the topic redistribution of the charge and loss of kinetic energy, potential energy. Redistribution of charge and loss of electrical energy. Electric potential energy. इसको पूरा बोलो सब and loss of electric potential. Potential. So redistribution will take place when the two charged conductors are joined by means of a conducting wire. Let Q Q1, B1 and C1 equal to charge, potential difference and capacitance respectively of conductor A. And now this Q2, B2, C2 is equal to charge, potential difference and capacitance respectively of conductor B. So we are having two conductors. This is now conductor A. This is now a conductor A. Now its charge is equal to Q1, potential is B1, capacitance is equal to C1. This is the another. This conductor B, its charge is equal to Q2, potential equal to B2 and capacitance equal to C2. So here we take that the V1 is greater than V2. So now what we have? You can have the total charge and now these conductors are joined. Better is to make it to be here. This is now your B, Q2, V2, these are the spherical conductors, V2 and C2. This is now first position, and now they are connected. This is A, this is now your Q1 dash, B and C1 connected to this conductor B, then the charge is equal to Q2 dash, V and C2. So here we take that this V1 is greater than V2. This is now second situation. Now in first situation they are separate from each other. In second situation they are connected by means of a conducting wire. Then charge will flow in this direction. Because we have taken that V1 is more than V2. So charge will flow from this conductor A to conductor B. So what is there? Now we take, and this flow will continue till the potential difference of the two conductors are not equal. And I told you that the potential, the electric potential is always gives the direction of flow of the charge. So charge always flows from higher potential to lower potential. Now here we are having the positive charge on both the conductors, and we have taken that the potential difference across this A is more than that of B, so the charge will flow from A to B. When conductors A and B are connected by means of conducting wire, the charge flows from A to B till the potential difference is not equal on both conductors. In both conductors, when V1 equal to V2 equal to V, the charge on conductor A and B will be Q1 dash and Q2 dash respectively. तो redistribution हो गया ना इसमें चार्ज का. Now this charge is has been तो चार्ज A से B की तरफ जाता है तो A पर चार्ज कम होगा और B पर चार्ज बढ़ेगा. और कब तक होगा? जब तक कि दोनों के पोटेंशियल बराबर नहीं हो जाते. तो ये जो पोजीशन होती है इसको हम कॉमन पोटेंशियल कहते हैं. तो टोटल चार्ज बिफोर connecting each other. ये कितना हो जाएगा? this Q equal to Q1 plus Q2। यहाँ पर चार्ज देखो बिफोर कनेक्ट नहीं किया है दोनों को चार्ज कितने Q1 Q2 तो दोनों टोटल चार्ज हो जाएगा Q1 plus Q2। So we have this total charge after connect each other. This Q dash is equal to Q1 dash plus Q2 dash. So what we have done here, this Q1 dash is equal to C1B, Q2 dash is equal to C2B, and here this Q1, the Q1 is equal to C1 B1 and Q2 equal to C2 B2. So following the conservation of charge, according to the law of conservation of charge, what we have, this Q1 dash, Q dash is equal to Q dash is equal to Q1 equal to Q1 dash plus Q2 dash equal to, this is now your Q1 plus Q2. Now we know these values. So this is now your C1B plus C2B equal to C1B1 plus C2B2. Or we take D common, then this is equal to C1 plus C2 into C1B1 plus C2B2. Or this B is equal to C1B1 plus C2B2 upon, this is now your C1 plus C2. This B is equal to so much. This is the common potential. This we call the common potential, where V is called common potential. V equal to common potential. So this we can have the formula, this total charge upon total capacitance. Now this we take now equation number 1. Therefore, common potential equal to total charge upon total capacitance. This is now equal to V. This is so much. Here we are having the total charge Q, that is Q1 plus Q2. This is our total capacitance C1 plus C2. Now we can have the potential energy. Now this Q1 dash, as you are looking this Q1 dash upon Q2 dash. Q1 equal to C1B, this is now upon C2B. So this Q1 dash upon Q2 dash equal to C1 upon C2. It means that the redistribution of charge takes place according to the capacitance of the conductor. So the conductor having more capacitance will have more charge, and conductor having less capacitance will have less charge. Redistribution of charge takes place according to the capacitance of the conductor. Hence, redistribution of charge takes place according to the capacitance of conductor. So Q1 dash C1 can become Q2 dash C2. So this we are having the redistribution of charge takes place according to the capacitance of the conductor. Now, since the charge is flowing from the conductor A to the conductor B, then there will be a change in the potential energy. So let us find what is the change, and definitely this is being the charge passes through the conducting wire. So the conducting wire will be heated up. So whatever the loss in the potential energy that appears in the form of heat. So let us find the loss of the electric potential energy. So now initial energy, initial potential energy, U1 is equal to half C1 B1 square plus half C2 B2 square. This is before charge, before connecting the two conductors, and the final potential energy U2 is equal to half C1 B square plus half C2 B square. So this is equal to 1 by 2 C1 plus C2 into B square. Now we will put the value of this common potential. So this is equal to half C1 plus C2, and the common potential is, this is your C1 B1 plus C2 B2 whole square upon C1 plus C2 whole square. This is the value of V. So this one term will cancel by this one. So what we have? 1 by 2. This is your C1 B1 plus C2 B2 whole square upon C1 plus C2. This is equal to U2. अब इसमें अगर एनर्जी का लॉस होता है तो U1 must be more than U2. सो लॉस के लिए हम क्या करें, जो इनिशियल है उसको खंड में से घटा दें उसको, तो लॉस ऑफ एनर्जी आ जाएगा। Loss of energy delta U equal to U1 minus U2। अब ये हम जानते हैं कि इसमें पहले से ही we know that there is a loss of energy because whatever energy is lost that appears in the form of heat in the wire which connects the two conductors A and B. So since the heat energy is appearing, it means that there is a loss of this potential energy. So this is equal to half C1 B1 square plus half C2 B2 square minus half. This is now so much C1 B1 plus C2 B2 whole square upon C1 plus C2. Now half is common in all and we take the LCM C1 plus C2. So this term becomes delta U equal to half and this is equal to C1 square B1 square plus C1 C2 B2 square plus C1 C2 B1 square and plus C2 square B2 square minus C. So it's now C1 square B1 square minus C2 square B2 square minus 2 C1 C2 and B1 B2, and this is we have taken the LCM C1 plus C2. This is not so much. So now you see that this term will cancel by this one and this term will be cancelled by this one, and C1 C2 C1 C2 C1 C2 is common in all. So this delta U equal to 1 by 2 C1 C2 upon C1 plus C2, and this is what we have, this B1 square plus B2 square minus 2 B1 B2. This is now whole square of B1 minus B2. Since we have taken that B1 is more than B2, so this is so much, and if we take suppose B2 is more than B1, then this will be B2 minus B1 whole square. So you see that this delta U is equal to 1 by 2 C1 C2 upon C1 plus C2 into B1 minus B2 whole square. This is the loss in potential. You see that this B1 minus B2, this may be negative, but due to this square, this is always positive. It means that delta U is always positive. Since B1 minus B2 whole square is equal to positive, so delta U is equal to positive. It means that this U1 minus U2 is equal to positive, or this U1 or this U2 is less than U1. तो क्योंकि इसकी वैल्यू पॉजिटिव होती है, इसलिए डेल्टा यू का मान पॉजिटिव होगा। इसका अर्थ यह है कि भाई डेल्टा यू का पॉजिटिव है, U1 माइनस U2 पॉजिटिव। इट मींस दैट U2 का मान जो होगा वो U1 से हमेशा कम होगा। सो thus there is loss of electric potential energy when two charged conductors are joined by a conducting wire. This loss of heat, this loss of energy appears in the form of heat energy which increases the temperature of connecting wire. There is loss of electric potential energy which, when two charged conductors are joined by a conducting wire, this loss of energy appears in the form of heat energy which increases the temperature of connecting wire. Now, whenever we are having the two conductors and they are joined, then sometimes what happens that we are asked the percentage loss of the energy. Percentage loss. तो परसेंटेज कैसे निकालेंगे? एनर्जी. Let B1 equal to V and B2 equal to 0. This we are having the first is at the potential V and second the potential is 0. So then delta U equal to, this is equal to now your half C1 C2 upon C1 plus C2 into V square. Now what we have, the initially this U1 equal to half C1 V square. तो परसेंटेज लॉस कितना हो गया? Therefore delta U upon U1 is equal to, यहाँ से इसको करें तो हाफ C1 V स्क्वायर कैंसिल हो जाएगा, तो ये आ जाएगा आपका C2 अपॉन C1 प्लस C2. आपको परसेंटेज लॉस निकालना है. डेल्टा U अपॉन U1, this is equal to C2 upon C1 plus C2. This is multiplied by 100. So this will be the percentage loss of energy. So definitely you know that this C2, whatever the value of this C2, this term is always more. So because of that, the energy will be always less than 100%. Not the complete energy is converted into heat, but a small fraction is converted into in the form of heat energy. So in this way you can calculate the percentage loss of the energy. This is generally asked in the competitive exams. So what will you remember this formula? Here this is now first we have V1. So V1 for this is now for C1. So this is now your half C1 V square. Then we find to this one and calculate the percentage loss. So this is about the potential energy, redistribution of charge, common potential, loss of potential energy and percentage loss of energy. Thank you.